Okay, I think we're back up. There we go. Okay, we'll see if this comes back in just a second. But I think let me tweet out what just happened there. Effectively, though, my internet just completely died for no reason whatsoever. Just crashed and burned. There we go. Starting to have some things come back. Hopefully this thing will update soon. There we go. Okay. Yep, we're live. Sweet. I apologize. That was the weirdest thing, but unfortunately the internet just decided to completely tank. So, if you're still here, thank you for sticking through that. And let me know if you see any other issues or anything, although you may have tried to and I didn't see it because, everything died. All right, let's get back to it then. Hilt NeoPixels. Oops. All right. Let's see what they have to offer us here. LED addressable. Actually, let me check something real quick. All right. Oh, reset the page. All right, NeoPixels. Specialty addressable LEDs. And there's going to be so much different stuff here. Well, this looks fun. $20. And just a bunch of them. That's effectively what I want. I want an RGB and an RGBW. Or something like this. So effectively what I want to do is do something like this in the hilt. Like a big ring circuit board and then all of the LEDs in it necessary. And then have that in like the right at the top of the hilt where the blade meets it. And then have those light pipes, these ones, like poking out at the top and wrapping around and coming down the hilt in some sort of crazy circuit pattern. And I think that'll look really cool, and they'll be fed by a ring of NeoPixels at the top. But I don't want to just buy a ring because I don't think we'll be able to get the right size. Well, maybe actually. All right. Let me just look at this and see what the size is. Outer diameter 1.45 inches. 92. That might actually be pretty close, but I still think we make our own, just to guarantee that it's the exact right thing that we want. Okay. Stream might still be having some issues. It's trying its best. Whoops. Let's get this out of the way. So yeah, we gotta pick one of these. And it looks like there's not many that are just separate like this. WS2811. I think that means that these are the slower communication variant. I guess it doesn't have to be that fast because there's not going to be many of them. But I do need to know. Oh, it may actually be really hard to solder these. VD's 5 volts. Static power consumption. Speed of data transmission, 800 kilohertz. All right, I think that's solid. I mean, that's what I was hoping for, so. And the breakdown should be here. 0.2 microseconds, 0.32, 0.4. So that's what you aim for. Okay. Effectively this. All right, yeah, if it's 800 kilohertz, I think we're fine. Assuming, of course, that I can solder it. All right, I need package info. Humidity indicators. All right, let's probably be back near the top then. Yep, here. I don't see this being easy to solder. So that's going to be a problem. But I don't know if there's any better options in terms of that. Because pretty much everything's the same type. Well, let's see. Does this say number of LEDs 100? Okay, so it comes with 100 in the package. That's pretty good for the price. And then I don't see anything better. That would be easier to work with at least. And it's not also insanely expensive. It's the pricing on these, $5 each. Oh, you get 10 for $5, okay. But pretty much the same difficulty, so we might as well go with these ones. All right. Going with this. Adafruit 4957. And then I'll just have to figure out a way to solder them. It looks like it may not be too bad, so we'll figure something out. Okay, we're almost there. We need buttons, we need to finish up this, and we need to do the motor. Actually, don't want that there. I'm looking for this. This is what I'm looking for. S. Maybe this will show us what we want. Nope. K15S-8 ohm. There it is. All right, speaker. Also, how's the stream going, by the way? Did anyone of you have a report for quality? I think it's running okay, but just want to double check. All right. Oh, we were talking about getting this connector and everything too. Did we put that in here or write that down somewhere? I don't know that we did. Oh, I think we did for the batteries. We didn't for that. We might just solder it directly to the board. Well, maybe. Okay. JST ZHR-2. All right, good to know. I will find the one that matches that. Pretty good range. Plenty of cable. All right. If anybody knows how to, let's see. This is a speaker, not a buzzer, right? That'd be really embarrassing if it wasn't. All right, I need to find how to build a circuit for it. Oh, man, I'm tired. I guess I didn't think about volume on this. I'm looking at a circuit now with a volume control. That's basically just an op amp connected to a slider that controls the volume. I don't know if we do that or if we just assume that it only has one volume. Ooh, and Instructables. Okay. I should double check in here because I really don't know what I'm doing when it comes to this, and I want to make sure that I do this right. It doesn't have to be complicated because I don't want to control volume or anything. I really just want to do the basics of it. Excuse me. Okay. Maybe I could find another speaker that has a more complete, like, circuit. We can still use that one, but I just want to see a data sheet that explains better, like, the intended application. This was not it. Let's see here. Speakers. I wonder if they have a surface mount option. Because I know there's got to be some surface mount types like this. Micro speaker. It doesn't give a circuit though. Let's see what else we can find. You know, instead of using that one, we could always use a big like through hole thing like this. This company, whatever reason, doesn't have good data sheets regarding that. Actually, looks like a few companies don't. Let's try Adafruit just out of curiosity. Maybe they have something. I don't see us using anything from them. But I was hoping for a better description. Or not. 3968. Here, I'm looking at this. Alright, we can figure this out. Ugh. Basically everything they have connects into one of their boards. I was hoping something like this would give me an explanation, but it still uses a breakout of a certain type, so I don't know that we're going to get a clear explanation. It doesn't seem that complicated, though. It's more just a matter of I really want to know, like, there's a type of circuit that you put on it with a like a transistor or MOSFET, and then a diode and a resistor, and it kind of protects it against feedback, and just makes it easy to use. And I don't know, like, I don't know the rationale behind the different components, like what resistor to pick, what the man, I cannot think tonight, what the requirements of the diode are. So that's where I'm drawing a blank, and that's what I need to figure out. But let me know if you have any questions or ideas. Okay. Still trying to find something. Here, we could take out this manufacturer. Just need something different. Just gonna try different companies with different data sheets until I find one that explains a circuit. They're all just using an amplifier though for any kind of demo thing. This is one of those moments where I just don't know the right question to ask, or I'm sure I could find something. Yeah, we'll just go with the standard. I think, yeah, this is, so I'm just, from what I'm reading, sorry, I apologize, I kind of zone out while I'm trying to understand things. I think we go with the speaker just fine. We got to pick a MOSFET basically for this whole circuit, but that'll be good. All right, let's do the motor. Let's go take a look. Oh, that's not what I want. Vibrating mini motor disc. And then we have sensors. Just want to see what they offer here, because this is usually a lot closer to what I'm trying to do, so. They just have this one. This is probably like for like a cell phone or something. Oh, it's tiny too. All right. Yeah, I agree. That's one of the benefits of that, is we can kind of stick it anywhere in the hilt and then just run the leads wherever we need to go. This doesn't look very big, and I'm worried that it's not big enough. I mean, remember this lightsaber hilt is going to be sizable, you know, and ideally one day made out of metal, so it's going to be, although it'll be a light metal like aluminum or something, but it's not going to be the lightest thing ever. And there's a lot of batteries in here, which those are heavy. So, yeah, I think we need something a little bigger. Motors. I'm willing to bet most of these are going to be pretty small. This looks cool. Is this just the picture looking ridiculous, or is it actually just like crazy? Yeah, we could get multiple little ones. That could be cool too, because then maybe you could do some sort of effect with it, where it just like moves around in a certain way or something. What we got here? 6 millimeters tall. Okay, so it's not huge. It just looks big in the picture, but although it seems a little heavier than most of the stuff. Mounting is going to be a little tricky for this too, because you know it wants to shake itself loose. So this is a little PCB mounted vibrator. Can shake all the components off our circuit board, shake the connectors loose. I'm probably going to miss something really important because it's written in Chinese. Sponge. Alright, give me a drawing. There we go. Gray. Point 2. I actually can't see this. 10 millimeters across. So it's still only like a little less than half an inch. But a fairly good sized one. Mounting it would probably be tricky. It's about the same distance long as its width. This is still really small. We may need to do, you may be right, we may need to do multiple. That sounds like more of a solid plan. Oh good, if you just run like half an amp through it, it speeds way the heck up. How do we control that? Hold on. I know there's a circuit for this somewhere. Okay. Well, we're definitely going to be using a lot of MOSFETs here. I wonder if there's a chip we can use. So I like the idea of using this one. But We need something that can kind of let us control what's going on. I mean, I guess we could just turn it on off, but that's not quite as good. Is there such thing as like a... You know, I probably should have saved that one. Hold on. Let's duplicate that. All right. Motor drivers and controllers. Oh, good. They're going to be hard to work with. All right, we need DC. Because that's what this one is, I believe. Yep, DC. 3.5 volts. Really? Okay. That's going to be a little annoying to work with, the 3.5 volts. I really wish we had a... Let's see if we can find a 5 volt one. I would much prefer that. Active in stock DC motor. And then 5 volts. 2 remaining. Oh, well, that's a serious piece of machinery. How the heck do you mount that? Is it as big as it looks in the picture? Yeah, it is. 24 millimeters. It's almost an inch. All right, yeah, this is a pretty seriously heavy duty thing. Can pull up to 225 milliamps. Okay. I mean, I think that's reasonable. Maybe we get 2 of them? Alright. So then as far as a controller goes, is there such thing as a 5 volt motor controller? Alright, we want DC. Through hole, surface mount. I think this bridge thing is in reference to if it can go forward or backwards. I think you need a full bridge to go forward and backwards. You need a half bridge to go one way. We only need to go one way, so... Differential is cool, though, if you can control the amount. All right. Oh, $72 for this chip. Oh, how much was that one? $5 per. Or if you buy 1,200, they're only $3.50 each. How's our stream looking? Still good? Yep, okay. Looks good. Alright. So... let's see. As usual, we're limited in our package options. SOIC would be nice. I have no idea. Oh, I think it's a dip is the through hole stuff. Let's try it. Hold on. Picture not available. Typical. Yep. All right. P dip and dip are the through hole stuff, or SOIC. Perfect. So that's what we want. All right, SOIC, 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 not TSSOP. Dip. Boy, they make this hard to sort through with the numbering. I mean, I guess it makes sense, but man, this is annoying. So I see. Man, how many different possible types that'll work are there? All right, these are a lot of pins at this point, so that's probably good enough, right? Get us started. I'm gonna use something like this, honestly. I see motor driver, 2.5 volts to 20 volts. Pre-driver, half bridge. What does this look like? I know it's expensive. It's like 10 bucks. I don't have permission to access. I can't buy your part if you won't show me the data sheet. All right, try again. How about this one? It's a little cheaper anyway. Okay. Drivers, yada yada. DC and bipolar stepping motors. Does this fit what I'm looking at here? This is not a stepping motor, but it's just a DC motor. Okay. Oh, there's a lot going on here. So here's the circuit. And kind of what they give is the... Okay. Oh, they're okay, so like controlling one or controlling the other. Current outputs can get up to 2 amps using this, so that's more than enough. Tolerant up to 7 volts. Outputs are active and in phase with their inputs. In order to be enabled, we need to look at the schematic here, because what I want to know is what the voltage is to enable it, what's considered a high and low, and then how does that correlate with the voltage on the input. I love the big ground here. I bet this chip does get a little warm if you're really pushing it. TTL logic, okay. 1 amp, 1 amp, 1 amp, this should be fine. So VCC2, I think, is the motor drive. VCC1 is the chip power. I think that what that means is we're going to need 5 volts on the inputs for the logic. How can we do that? I guess we could use FETs to control it. As far as the circuit goes, how many external components do we need? Because it looks like it could be quite a bit. Application modes. So what's going on here? Oh, I guess there's diodes for like feedback and stuff on both ends. That makes sense. It's kind of weird how this is set up, but okay. I guess I gotta read this. I apologize. I need like a truth table or something. I know I saw them down below, but all right, 1 through 4A. Driver inputs, non-inverting. Driver outputs. Drivers 1 and 2, drivers 3 and 4. Heatsink connected to print circuit with multiple solid vias. Internal logic translation. Power for the drivers, 5 volts to 36. Interesting. Two, 7, 10, 15. Driver inputs not inverting. High level input voltage. 2.3 to VCC1. Oh, perfect. Okay, so we can drive this with a 3.3 volt micro, which is perfect because that's what the TNC is. The low should get low enough. Yep. Well, I think this will work. The only downside is it could just be another thing that's going to blow up, but that might make for an exciting video, I guess. So input is the A. Output. That's the test circuit. Okay. Let's go back to our application stuff to understand. Let me. I need to see this pinout because I'm not understanding. Enable 3A, 4A, 2A. Oh, okay. So I was looking at the enables as the input, but the enable just turns them on. 1A, 2A, 3A, and 4A are the actual like drivers, and you can control them all individually. So then how is this supposed to work? What is going on here? Is this some sort of like full H-bridge thing? Because that's what that looks like actually. This circuit where they have two drivers connected to this one motor looks like a way to rotate it forward and backwards. Yeah, that's exactly what's going on there. Okay. So I really just care about something like this. I'll have ground and a feedback diode. Okay. What is this? I don't understand this one. Oh, this is doing the opposite of what this one is. That's all that the circuit is. It's just showing you how to wire it up so that when this one turns off, the motor turns on, and this one, when it turns on, the motor turns on. Okay. Yeah, I think this chip is more than okay to work with. It's going to take. I want to. One more thing I need to look at. I just noticed this sentence up here. Where is it? Output diodes are internal and L293D. What does that mean? It's the L293. L293D. Two-phase motor driver. Oh, wait, they both are. Okay. So this one, they want the diodes on the outside, I'm guessing. And if you get this one, they're already built in for feedback, so you don't have to worry as much about it. Maybe. Oh, for when using it as a two-phase motor driver. Three for DC. This is what we want right here, really. What is this part number? Oh, it's a diode. Excellent. Look at these guys telling us even what diode to use. Now that is great. I don't know if it's still used, like if it's still in production, but is that a typo? Because it didn't come up anywhere. CS501. I saw the SE5001 did though. What is this? Device drivers. Okay. Nope. That's not it. Yep. Or rats. I thought I was getting lucky there a second. Okay, but they do provide a truth table for what's going on here. I don't want a bidirectional, I just want the one. So if you turn the enable low, that shuts down. Oh, okay, so that disables everything, so it won't just like stop, it'll just free run like spin, basically. Okay. And showing you like what they've done differently here. All right. We'll find a diode, but I like this part. We're going to use it. And as far as this monstrosity goes, I'm not sure if we're using this yet. We need to know how we're going to mount this. Doesn't exactly give us a lot of options here. Also, is this a single direction, or is this one possible to drive both directions? I want to use this motor because I think it'll be really good and useful, but I need to know how we're going to mount it. Let's see what this does. It looks like there's a slot here that we might be able to use. Nope. I thought there was. So there's not really any mounting points. We just have to somehow get it to stay on. That'd be kind of funny, actually. Well, I'm going to keep that open. Actually, you know what? Let's go ahead and knock out this thing. 93D. This is the one with the diodes inside it. I don't know if we want that one. Or if we want the other one. L293. Let's see if we can find the one that's not. What are our options here? NE. This is probably more like the one we want. Yep. I need to check this data sheet again. I need to know exactly what this labeling means. DNE, NE4, NE. Depends package quantity. What is the difference? Doesn't say. I'm sure it says somewhere. I get the difference between the D and the one without it, but what's the difference between these two? And 4. It's the only time that shows up anywhere in this data sheet. I would expect it to be like the temperature is different or something, but there's not even like that. Oh well. I don't think it's that big of a deal. I think this one is fine. L293NE TI. L293NE. There we go. Then, as far as the motor goes, we need to see if we can find a way to mount something easily or whatnot. Oh, that's right. This is the only one rated for 5 volts. As opposed to this one, which is much, much smaller. Yeah, this is that mini one. I suppose we go with this one and try and figure out a way to mount it. All right, so if we clear this voltage thing, is there like a common voltage reading? Oops. So far, no. 3 volts DC. That seems to be the popular one. We may want to redo our design specific to this because it will help us pick something. These are all tiny though. At least as far as I can tell. I suppose we go length of this, and that will, let's sort by that actually. Okay. Largest first. Supposedly. But they're not going to make mounting easier on any of these, are they? Let's see what we got here. All right, stream health is looking good, by the way. If you have any issues, let me know, but it looks like everything's holding on. after that early disaster. 6, 4, 8. That's a pretty good size motor. It's rated for 3 volts. Is operating is 2.4 to 3.6 volts. Doesn't tell us what happens if you go off the chart, but it probably is not good for it. I would like to do that, but this is only rated down to 4.5 volts. Yeah, I want to go with the 5 volt one. We can use the small one if we need to, but I'm going to try and use the bigger one. Whatever one we were looking at. This one, yep. Okay. Oh, we are so close. We just need to know these buttons now. We might change these ones on the fly, but I'm going to pick some out now. I fully intend to get buttons, tactile switches with really long actuators. That way they'll be fairly small, so they won't like stick out on the hilt or anything, but you can still use them. I won't have to use extra parts to get them to work. So something like this, right, where the button is really tall, but like more than that. They do make them. Well, we went through whole. Let's just sort. Actuator height off PCB. Highest to lowest. Let's see what we get. Yeah, there we go. Something like that. 48 volt. Man. That's a big switch. This is what I was thinking of. Something like this. Just because that gives you a lot of room to play with. This is going to be very tricky. There's no easy way to include a part that will change the length of this, like make it variable. So we're going to have to pick something that's definitely going to work and fit. And we're going to have to design around that. $16.3, 17. Okay. I'm just curious about this one. I want to see. It's an expensive switch too. Just wanted to see how big it was. Half inch, that's pretty sizable. Yeah. I think we go with something like I was originally thinking here. Like one of these. Really don't like the red one at all. Or the brown one. Yeah, black it is. All right. Looks like there's different heights we can pick from if we need to pick something different later. E-switch, E-switch, E-switch. Okay, so E-switch makes pretty much all of these. If you look at the data sheet here, I bet it'll show us a bunch of different heights. This series of random switches. All right, gotta understand this nomenclature. We just want the TL, not the TLE. That one. Actuator, dimension. Lots of different size options here. All the way up to 17 millimeter. All right. Force. Wow, they have a lot of different options here. The right angle options as well. Oh, they have a snap-on actuator head. That's really interesting. Looks like it only fits a certain type, though. Yeah, this thing. That's maybe what they're talking about? Maybe not. J. What's the J? Oh, square head. That's what that means. Square snap-on actuator head. That's not what caps are. What are caps? All right, we're going to have to give me something here. SP. Oh, okay, so it's just more, yeah, square snap-on cap. All right, we don't need that. This looks like a great option. We'll pick one at random, but we can, knowing that we can come back and find a different size later is great. Like, really great. So I'll copy this one for now. And then we might be able to come up with some little like thing where we can put buttons for it that match the color of the hilt or something. It'd be a little tricky, but we could possibly do it. Why did that happen? Whatever. All right, I think that is more or less the entire design laid out in all of its glory as of right now. Everything can change before we get there. I think next thing I want to do is confirm. Oh, you know what? We were talking about having this, having to have a circuit for the speaker. It just occurred to me while we were looking. Maybe there's a speaker like driver chip that we can use. Maybe there's not. Didn't know if there'd be something with a ton of speaker like circuitry already built in. There is audio amplifiers. Yeah, some of these packages are going to be pretty hard to work with. We need an 8 ohm. Amplifier. What does this look like? And there's no way I'm going to be able to solder that ground pad. Just want to see what our options are here. I probably don't need this open anymore. Okay. Speaker amplifier for automotive. Well, it's definitely robust. And output P, just a couple caps between. Input signal. You know, honestly, I kind of like this. It looks like it takes care of a lot of this stuff for us, which is what I was hoping for. What is SDB? Shutdown. Connect this pad to ground. Right. I will do my best. Not optimistic. Okay, yeah, and it has a whole kind of circuit inside. Overcurrent protection, things like that. All right, cool. We might be willing to go with this. I don't know what the package size is, though. And you can determine. Interesting. Oh, it protects itself if something's going wrong. I think I should plan when we do this on buying these components a few times because this is a pretty complex. I mean, look at what we're coming up with here. This is going to be a really complex circuit board. Any number of things could go wrong here. And so we need to be ready to fix those things and then order again if we need to. Okay. No, but this might work. Maybe. I need to see the speaker again. Hanging in there. Okay. Maximum power, 1/2 watt. Eeh. All right, that part will actually not play well with this device. Yeah, because it's 1.2 watts. I guess we could probably cut that down. Because, yeah, it looks like a lot of our options are pretty high powered. Is there a way to lower the power? Interesting stuff. Alpha power 1.2 watts typical. Yeah, that's too much. Unless we pick a different speaker. Honestly, probably a better idea. Let's pick a speaker that'll fit. Stock, active. All right. Is this a common one, 1.2? It looks like it is. Let's see what we get here. Some pretty expensive stuff, but some more reasonably priced. Maybe we should, I don't know if we need to go with that or if we need to go with just everything that is higher than a certain amount. Yeah, I probably don't need that much. Maybe like up to 1 point, up to 2 maybe. Oops. Let's see what this gives us. Activity, $3. Not big enough range. It probably is fine, but interesting. I like the mounting on this, but this might be too big. 25 millimeters. Oh no, it's small. It's like only an inch. Yeah, we might be able to make this work. How does it connect? Frame mount. Yeah, I mean this is perfect. We can fit this wherever we need to. This power is 1.3, impedance is 8. Nominal power is 1. $9060B at 10 centimeters. Wow, that's loud. We may not use the speaker if it's like crazy loud, or we'll have to figure out some way to insert a. Oh, you know what? I might be able to put a resistor or something in there that we can adjust. But yeah, I like this one. I just wish I knew how it was mounted. Let's go to the company website. Ooh, drawings. Still tells us pretty much nothing. Where do they have a model? I like that it's a high temp variant too, because, you know, with all the batteries and how hot this whole thing could get. Let's see. Nobody seems to know anything about this particular one. All the pictures of it are just from the front, so it doesn't tell you anything. I'm assuming there's contacts or something on the back that we can solder to, but I just don't know. Looks like there's more than one company that makes these, though. We might be able to get away with $4. Which one did we click on? I'm able to find somebody who's at, here we go. It actually gives a picture of what it looks like. Yeah, with some leads. Oh, that's great. Probably pick this one instead because it's easier to understand. Oh, it's huge. Did I read that wrong? Was I reading it in millimeters, the other one, when it was centimeters? They don't give a unit. At least that I can see. All dimensions are in millimeters unless otherwise noted. Okay, so this one actually is tiny. Oh, is this talking about measuring? Okay, I thought that was the drawing of the part. I was like, oh man, that is enormous. I need an actual drawing. Unit millimeters 20 40. Okay. This one's definitely bigger. But I think we still work just fine. Well, actually, no, this one could be a problem. This one's pretty sizable. Compared to this one. I think we'd probably be better off with that one. Here it is. Yeah, and it's a little cheaper. I think that's because of, yeah, it's smaller. Let's just look at this one. Millimeters, 28, 40. Ah, that's ridiculous. All right, I think I'd go with that first one that I found, actually, because it's smaller. I like these ones with mounting points, though. That definitely makes that a little easier to work with. Is that mentioned here? Mentioned heat, ingress, material, cone, shape. I don't see it mounting, unless I'm just missing it. Alright. Let's go with this one, the SC2507. Oh, that one company we were originally going to buy from has their own version of it. $4. Yeah, we'll go with the other one. Since I don't really want to know what I'm doing, I don't want to spend a lot of money on it in case it doesn't work. Just try it. If it works, great. If not, oh well. At least it wasn't that expensive. Where did it go? SE250708. Well, we know it's DB Unlimited. Let's just filter on that. Any other filters? Nope. Okay. There it is. All right, new speaker option. Okay. And then our driver, we were looking at this one, I think works for this, but I need to know the size of this. I need to know how hard it's going to be to work with by hand. What's the spacing? 1.27 millimeters, so that's 10th inch. That's kind of SOIC-ish. It's 1/10 of an inch. I believe that's what that spacing is. Oh no, 2.54 would be 1/10 of an inch. Those are 0.5 millimeter spacings. Ooh, that's tiny. I'm not feeling great about that one. Well, crap, we just picked a speaker for it. I mean, I want to try it, but that's a really hard thing to solder by hand. SOIC. These ones are not showing any. Oh, they are SOIC? Really? I guess they are. SOIC is just a lot smaller than I remember. Alright, we're going to give it a shot. See what happens. What's the difference between these? Explain the part number to me, please. Voltage gain. 783. Yep, 3102606. So 1026 and 06. So the highest or the or some of the lower ones. I don't know what gain to use. Do we go for the loudest? Let's check out both, see what's different here. I thought max output power was 1.2 watts. Did I miss something? .2 watts typical. Right, we'll just see what happens. I'm going to learn a whole lot about speakers in this stupid ordeal. Alright, then what's different here? I think it is just the gain. Yeah. Voltage gain is from 6 dB to 26 dB. I'm just scared to go too high. Because I don't know. Well, let's pick a version of this chip and then we can double back and verify. Although I really hate doing that. This doesn't say anything about it. Amount. All right, I'm just gonna go with it, see what happens. And hopefully nothing explodes or catches on fire. Amplifier voltage gain explained. Oh, there's definitely some stuff to go through here. All right, I'll have to read more about it off stream. But this will be a good start. Need to mark this as like needing to be validated or something. Let's not pick the 26 by default. Let's pick the 6. Just in case I'm like, do this horribly wrong. At least we were underpowered and hopefully nothing explodes. All right. I think we finally have all of the basic parts picked out. So the next thing is going to be going through. So now that we got all this, we'll have to start a new circuit board project, and we're gonna have to go through. And first, we need to, in a bill of materials, list all these parts and mark certain ones with like, you know, verify or something if we still need to validate them or whatever, any kind of notes we have. Then we need to create a spreadsheet with the teensy and mark what all of our inputs and outputs are going to be used for. Because obviously there's a lot of different, we need PWMs, we need I2Cs, SPIs, you know, USB, uh, basic GPIO, voltages in and out, you know, speaker, like all this crazy stuff. So we need to go through and label where everything's going to come into the teensy at, like just to make sure that we have enough IO to use for everything. You know, we can, because just because there's, you know, enough pins for all this doesn't mean that all the pins have the items that we need. Only certain pins have PWM, only certain pins have SPI, only certain pins have I2C. We need to make sure that there's enough of all that stuff and that it's in the right configuration that we can use it all. So once we do that and create the spreadsheet with all of those connections, and then we'll mark them with what they connect to and all that stuff as best as we can, then we'll have to go through, we'll start the project and create the schematic. And that is going to be a big undertaking, and I cannot wait to see what it produces, but it should be good. So next time we'll work on the bill of materials and we'll work on the pinouts, make sure we understand where everything is going and what is required on everything. And then we may have to create the schematic in tandem to actually understand it really well. I also don't know if there's a TNC 4.1 package on Circuit Maker. We might have to make our own, but that's fine. Okay. Well, good work for tonight. Sorry again about that internet crash at the beginning. I know that effectively killed my audience because most people left, but that's all right. These things happen. So I will see you all again on Thursday, where we will continue to try and knock this out. And then I think next Tuesday's stream I'm not going to be able to do. I think I have prior commitment, but I will keep you all updated on Twitter. So just follow me on Twitter and you'll get updates for everything that I'm working on. All right. I will talk to you all later. Bye.